Okay, so I'm not used to writing on this pad. This is something new technology, so I apologize. Please bear with me during this recording. But this is a review of Chapter 4, the quiz that you'll be taking online. So we're going to start with the first one as asking for us to take this whole number, which is 4 2/3, and they want us to convert this to a mixed number. And I apologize. Give me a little bit and I'll get used to writing on this board. So the goal is to take this number and multiply it by that one, and then we're going to add this number in. But this number here, a denominator, will never change. So what does that look like? So let me rewrite that. It's 4 2/3 equals. So on the top of it, again, it would be 4 times 3 plus 2. And you have to perform order of operations. And the 3 will never change. The denominator never changes. So if we perform that operation, that would be 12 plus 2 all over 3. And our final answer would be 12 plus 2, which is 14 over 3. Now we just converted that to a mixed number. So the answer for 4 2/3 converted to a mixed number is 14 over 3. And there's our answer. Okay, so moving on to the next one. They want now to take this mixed number of 43 over 8, and they want us to convert that to a whole number. Okay, and my strategy, I've always converted this into a decimal problem. I'm sorry, excuse that, to a division problem. Okay, so I'm going to rewrite this as a division problem. So I'm going to take 8 into 43, and I know that 8 times 5 is 40. I'm going to subtract it out so I can get my remainder, and my remainder is my numerator. The denominator never changes. This is your denominator. That will never change. And if I was to rewrite this, you can see that the 3/8 is already in the lowest form. So 43 over 8 as a whole number would have 5 3/8 as your final answer. Okay, let's move on to the next one. Now the next one, they want prime factors. So if I have a number such as 12, I'm going to break that up. Now they can be broken up 2 different ways. You could either choose to use 2 times 6, or you could have chose to use 3 times 4. So I'm just going to go ahead and use this first one, and know that right here that the 6 will be broken down as 3 times 2. So I'm going to rewrite that. So 2 times, and then to represent my 6 is 2 times 3. And I'm just going to, in my final notation, gather my 2's. There's 2 of them, times 3. And if you were to plug that in your calculator, you would get the answer 12. Same thing with the 3 times 4. 3 times, and we know that 2 times 2 equals 4. And then if we're going to gather our numbers and our final notation, if you were to plug that into the calculator, you would get the answer 12. So that is your prime factors. Okay, let's move on to the next problem. All right, now the next one, we're going to write this fraction in simplest form. Okay, and it's 25x on the bottom. All right, now I know that for both of these, I know I can get a 3 times 5 out of the 15, and I know I can get a 5 times 5 out of 25. So I'm going to go up here and I'm going to rewrite it. 3 times 5, and I have this squared, so I have 2 x's there. So I'm going to write it out 1, 2 times, all over. And now we know that 5 times 5 is broken out to 5 times 5 times x. Now I'm going to say, okay, now whatever I have on the top end is on the bottom. That will reduce down to a 1. I have 2 x's here, but I don't have another x on the bottom, so that must stay. Same with the 3 and 5. There's no more 3's and 5's. There's no 3 on the bottom, there's no 5 left on the top. So I'm just going to gather that, and my answer would be 3x all over 5. And that right there is my final answer. Okay, let's move on to the next one. Now, the next one, we're going to go ahead and we're going to multiply two fractions. So my fraction I have is negative 11y all over 20 times, we have, oops, sorry, it's very sensitive pad. I apologize about this. So a negative times 4 all over 5y. Okay, now the first thing I always recommend is to rewrite it as a whole fraction. So if I rewrite it, I'm going to rewrite it as negative 11y, let me make this a little bit smaller, times 4 all over 20 times 5y. Okay, so I'm going to start doing an evaluation. When I look at this, I see there's a 4 on top, and I know right here I can get a 4 times 5 out of that. So if I'm going to rewrite that, and I apologize, I'll write this a little bit neater. I'm going to rewrite it as, so let's move this over. So if I have a negative 11y times 4 on the top, now the bottom of my fraction, I know I have a 4 times 5 to represent that 20 times 5y. So immediately I start evaluating what's on the top and the bottom. Well, I have a y on the top and the bottom, so we knew that reduces down to 1. And I also have a 4 on the top and the bottom, which reduces down to 1. So now if I rewrite that, I'm going to rewrite it as a negative 11 over top, and then we're going to take 5 times 5 right here, and we know that is 25. So there is our final answer in simplest form. So what we originally did is we took this number, we multiplied it, and then we made sure in all these steps that when we multiplied it out, we went ahead and we reduced it before we multiplied it. Okay, so let's go ahead to the next problem. Alright, so the next one is negative 15 over 28 divided by 30 over 7. Now, we learned that when we handle these fractional problems, we first have to convert that to multiplication, and then we're going to take the reciprocal of that number, which is 7 over 30. So let's go ahead and rewrite it as a multiplication problem. So we have negative 15 over 28 times, and then here's our reciprocal, 7 over 30. Okay, now we're going to rewrite it. I always rewrite it to have one fraction, so it's negative 15 times 7 all over 28 times 30. So the first thing I'm going to start saying to myself, well, I can see right here I can get a 3 times 5, and then I can get a 5 times 6 here. And in this one, I'm going to be able to get a 7 times 4. So that's how I want to start breaking it up. So let me go ahead and rewrite that. So equals negative 3 times 5, that would give me my 15 times 7 all over, and for my 28, I'm going to break it up as 7 times 4. I apologize, it's a 7. It's awful. Times, and then for my 30, I have 5 times 6. Okay, now I'm going to start evaluating what I can do a process of elimination, where there's a 5 on the top and a 5 on the bottom. Here's a 7. These 7s, there's 1 on the top and there's 1 on the bottom, so that gets reduced down to a 1. Now, when I rewrite this, I can see already that this 6 right here, that'll break down to a 3 times 2. So I can break that down even further. So let me rewrite that. So let me regather my stuff. There's a negative 3 on top. And on the bottom, I have a 4 times. Now, this 6, I'm going to go ahead and rewrite it as 3 times 2. Now, I immediately could see this and this. There's 1 on the top and there's 1 on the bottom, so it reduces down to a 1. So on the top now, I have a negative 1, and on the bottom, I'm going to multiply out my 4 times 2, which is an 8. So here's my final answer. So of this problem, again, we started up here at the top as a division problem. We rewrote it as a multiplication problem, making sure we use this reciprocal, and then we used we simplified it by breaking it out into prime factors, and then we made sure we noticed what would reduce down to a 1, and then we end up with our final answer. Okay, moving on to the next one. Okay, so now we're going to add fractions. So if I have negative 7, oops, let me turn that back to black. If I have negative 7 over 20, and I want to add that, and I'm putting this in parentheses only to protect that negative sign. So, apologize about this. So this is 9 over 20. All right. So now, the first thing we're going to look at, you always think, now if I'm going to be adding fractions, adding or subtracting fractions, the first thing I need to ask myself, are these the same? Are they common denominators? If they are, then your work is easy. Then all you need to do is just rewrite that as one fraction, negative 7 plus a negative 9 all over 20. Oops, sorry, it's pen. So now we have to apply our integer rules, and we've learned that when we're adding two negative signs, we just add them up and take that negative sign. So our answer to this would be negative 16 over 20. But I can see that's not in simplest form, because when I evaluate, I can see I can get a 4 out of the top and I can get a 4 out of the bottom. So I'm going to go ahead and rewrite that. So my negative 16 I know can be a negative 4 times 4. And then I know my 20 is a 4 times 5. And we can see that we have a 4, we have a 4 on the top and a 4 on the bottom, which becomes a 1. So now I rewrite that as a negative 4 over 5. And that is your final answer. Let's start another one. Okay, now this is adding a fraction again, but the denominator looks a little different this time. This time we have an x. So, and this is 7 over 4x. Now, when I look at this, these are exactly the same. Now, if one was written like this, then it would be different, but that's not the fact. So we're okay. So they are common denominators. Since they're common denominators, we can go ahead and rewrite that as 3 plus 7 all over 4x. So now all we have to do is perform the addition on the top, and once we do that, we know our answer is 10 over 4x. We can see that's not in simplest form because we can get a 2 out of both of them, because we know that 10 is 2 times 5, and we know our 4 is 2 times 2, right? So we're going to rewrite that as 2 times 5 all over 2 times 2, and don't forget your x. We don't want to change the value. We're just simplifying it. So we can see we have a 2 on the top, a 2 on the bottom, which reduces down to a 1. So now we have a final answer of 5 over 2x. And there's our final answer. Okay, let's move on to the next one. Alright, now you're going to have a problem when it asks for your perimeter. The perimeter, make sure you just gather and you add up all the sides. And when I looked at my problem, I had all my sides were all in inches, and these were my fractions. Now, again, the first thing I look, I said, okay, well, the perimeter, I notice all of them, their denominator is the same. So we're okay. There's no change that has to occur there. All I have to do is rewrite it as one fraction. So that would be like this, all over 22. And then I just add everything up. And when I do that, we end up with 22 on top and 22 on the bottom. And we know when the numbers are the same on the top and the bottom, that is just equal to 1. And it was in inches. So our perimeter is 1 inch. Now I'm going to stop here and start a part 2 to finish working on these problems.